Hi, I'm Rink, play defense for the Cincinnati Cyclones. This is my third season of pro hockey. I attended Quinnipiac University and majored in sociology. I've been playing hockey since I was 2 years old.
Hi, I'm Jimmy Kilpatrick. I play forward for the Cincinnati Cyclones. This is my second season as a pro hockey player. I attended Colorado College and I majored in economics. I've been playing hockey for 20 years.
With data analysis, you need to figure out exactly what the experiment you are conducting consists of. Then you can move forward with collecting and calculating the problem and trying to find the right answer. Once we know what these numbers look like, we can try to figure out the probability of these things happening again. First, you will see one of the Cyclones defensemen shooting pucks at the net. The net is approximately 64 feet away from the blue line. The defensemen, who usually do not jump up in the play much closer to the net, will be able to put 2 out of 5 pucks on the net. During the course of play, other players will get in the way and tip the puck out of the scoring area or keep it from getting through. Next, you will see one of the Cyclones forwards in the slot area. The slot area is a higher percentage shooting area, as it is directly in front of the net and about half the distance from the goal as the blue line. Players in this area will get the puck on goal about 3 times in 5 tries. Defenders will try to knock the puck away in this area, but it is much tougher to do than all the way out at the blue line. Now that you can see the probability of making a shot, where do you think the better location for taking a shot would be? If the defenseman makes 2 of 5 shots and the forward is able to make 3 of 5, what is the likelihood of the forward scoring versus a defenseman? Would they be the same? Should the forward score more often?
During play, we can't always have the play directly in front of the goal. The opponent will try to close down that area. As the angle away from the front of the net becomes more narrow, the percentage of the scoring chances from these angles reduces also. A puck on the wall is half as likely to go into the net as one in the slot. Why do you suppose that is? When a player goes to the penalty box, the other team gets a power play. The power play is a great opportunity because the opponent only has 80% of its defenders on the ice during the time it is shorthanded. A really good team on the power play will score 25% of the time, or about once every 4 times. Cyclones are scoring about 20% of the time, or once every 5 times they have the advantage. The league average is 16%, or about once every 6 times. If a really good team gets 8 power play chances in a game, how many goals do you think they would score? If an average team gets 6 power play chances, how many goals would it score? If a really good team and an average team each get 100 power play chances in a 10-game window, how many goals would they score? What would the total difference in goals be if they scored at the rate of their percentages? Over 10 games, can you see what a difference this would make?
Hi, I'm Barrett Agates. I play forward for the Cyclones. This is my 5th season of pro hockey. I attended Niagara University and I majored in business. I've been playing hockey for 23 years. In hockey, we count on the goaltenders to keep the puck out of the net. Every time they stop a puck, we call it a save. Save percentage is a statistic that shows how well a goaltender plays and allows us to have a chance to win. The Cyclones have 2 very good goaltenders in Robert Mayer and Jeremy Smith. Jeremy has a save percentage of 92% and Robert stops 90% of the pucks he sees in games. We know the Cyclones stop 91 pucks out of 100 for the season. We know that 91 pucks plus X equals 100%. How do we figure out the X? Since we're adding X to 91, we can solve it by subtracting 91 from 100. When we figure out what the number is, that is the number of goals we are giving up. How would this number be different if we knew the Cyclones forwards were scoring 16 on every 100 shots? Which of the following might be the best way to solve this equation?
Hi, I'm Brock Sheehan. I play defense for the Cincinnati Cyclones. I graduated from the University of Notre Dame with a degree in finance. I've been playing pro hockey for 2 years, and I started playing hockey when I was 5 years old. One of the really neat things about the Cincinnati Cyclones and US Bank Arena is the fact that we get to play ice hockey indoors. As you saw up on the video board earlier, we take our cement floor and by adding lots and lots of water and cold, we build it into an ice rink. We start with just the boards around the rink and the floor, and as we add water, it starts to build into our ice sheet. We then add white paint, and as we add more water, we then paint the colored lines and logos on the ice, and then we build it up even more. Let's see how this is like math. The board surround the perimeter of the ice rink. It holds everything in and serves as a boundary point. Think of it as the outside of a circle. The space inside the boards is our ice rink. In math, you would think of this as area, the top surface of the area. But what about volume? There's volume in our ice rink also. That's the layers of water that are built up on the concrete floor and makes this three-dimensional object. It takes about 10,200 gallons of water to make our ice rink only 1 inch thick. 1/16 of an inch is a little more than 600 gallons of water. The Zamboni, which resurfaces the ice between periods, is capable of laying down almost 1/16 of an inch of ice if it does not cut any ice. How many times would we have to send the machine out on the ice if we wanted the sheet 1.5 inches thick from the start of the project? The older students will recognize the formula on the screen and see just how many times it would take.
Hi, I'm Scott Reynolds. I play forward for the Cyclones. This is my 4th year of pro hockey. I attended Mercyhurst College and majored in finance. I've been playing hockey for 25 years. In hockey, we use elapsed time for telling when things happen. The clock starts at 20 minutes and counts down to 0 like other sports. The difference is in the way we report it. Let's say the Cyclones get off to a fast start in a period and scored with 19:53 left on the clock. We do not list on the score sheet that they scored at 19:53. Instead, we figure out how much time has gone by. When we subtract out the 19:53 from the 20 minutes, we see that the goal took just 7 seconds to score. Likewise, if at the end of a game a friend tells you the team scored at the 19:57 mark of the 3rd period, you know that the goal came with 3 seconds to play. We do this with scoring, penalties, and how much time the goaltenders play. Figuring out the elapsed time allows us to calculate how much power play time a team has. It also allows us to figure out a goaltender's goals against average, which is a complicated formula that your teachers have if you'd like to try out a problem or two. Being able to quickly figure out elapsed time is good for the officials to understand, as they need to be able to calculate when players get to be released from the penalty box and join their teams in play.
Hi hockey fans, Frank Marzullo from the Fox 19 Storm Tracker Weather Center. Glad to be with you here at US Bank Arena. We are going to be talking about cyclones. And I tell you what, there are so many different cyclones, not only the ones that take the ice right here at US Bank, but there's also cyclones that affect our weather. One of those cyclones is called a low pressure system. Now, it's that big L that's on our weather maps, okay folks? And basically, I call it lousy weather. It brings us wet weather. Cyclones, low pressure systems bring us cloudy weather and also brings us some cooler air. Now, with a cyclone, with a low pressure center in the northern hemisphere, which the United States, North America, in the northern hemisphere, you have winds around this cyclone in a counterclockwise rotation. So wherever it's positioned on your map, let's say it's positioned just south of greater Cincinnati, you're going to have your winds coming out of the south, so a little warmer. If it's positioned a little bit to the north and east, we're going to have a little cooler air coming in. Now, in the southern hemisphere, the cyclone, well, it's the opposite. It has a clockwise position. Places as you work down towards Australia and down under. Now, on our weather maps, when we talk about the forecast at Fox 19, the low pressure center controls a lot of our weather. It brings us our wet weather, as I mentioned. It also brings us some cooler air, depending on the positioning. And that lousy weather maker that brings us our saturated air, well, it travels along the jet stream. The jet stream acts as the freeway of weather. We take our cars on the freeway, we get off at one exit, we travel from point A to point B. Well, the jet stream allows our weather, meaning our cyclones, to travel from point A to point B. So everything travels along that jet. Now, hurricane season just about coming to an end December 1st, and hurricanes are basically intensified low pressure systems, which are tropical cyclones. Now, to put this in some perspective for you, how do tropical cyclones get their strength? Well, basically, you have that counterclockwise rotation in the northern hemisphere, and as long as you have the warm waters of the oceans or the warm waters of the Gulf, well, those hurricanes, they can intensify and they become enormous. In fact, they start to form eyes. And not only do they bring major wind damage to coastal cities such as Florida and Texas, we had a tropical storm, Ida, just a few days ago, but it also brings heavy rain. And once these systems then get onto the mainland of the U.S. or any surface, with the exception of water, they lose strength because those warm waters obviously give them their strength. Also, you have tropical cyclones and you have smaller cyclones as well. Tornadoes. Tornadoes have affected us here in the Cincinnati area, and they can be anywhere from 80 miles per hour all the way upwards of 250 miles per hour. So a little weather lesson for you. Enjoy the game, and now back to the Cyclones on the ice.